Hey guys, welcome to lesson 413, where we are going to be learning how to find solutions to systems of equations now, as opposed to just equations like we had been doing before. When we're solving a system, that means there are multiple equations involved, and this time we need to find x and y because now we actually do want the entire intersection point as our answer, as opposed to just the x value like we've been doing the last 2 days when we were solving equations. So what this is the solution to a system of equation is just the point where they intersect. And so we are going to find those points algebraically, though you can always, of course, do them graphically as well. So to start, we can see this right over here is our first system, that y equals negative 5x plus 1, and y also equals negative 2x minus 2. Now, if both of these things are equal to y, then it only makes sense that they also must be equal to each other. So we can set them equal to each other, since they are equal, if they're both equal to the same thing. And then this just becomes one of those basic equations for us to solve. So I can go ahead and move things around. Let's add 2x to both sides to get our x terms together. So here we have negative 3x plus 1 on the left, and negative 2 is left on the right. And we keep going. Let's subtract 1 from each side. Oop. Bad line. All right, so on the left, we are left with negative 3x, and on the right, we are left with negative 3. Our last step would be to divide both sides by negative 3 to get x completely alone, and then we get an answer of x equals 1. Now, if we were solving an equation, we would be done, but since this is a system, there are x's present and there are y's present, we also need to find y. So in order to do that, we need to plug this in to one of the original equations. Okay, we need to plug in to the original equation to find y. So what I mean by that is I will take this 1 for x and I will plug it into any of these. It does not matter which one, so I'm just going to use the first one. Regardless of which one you plug it into, you'll get the same answer because it is an intersection point. So using that first equation, I will say that y equals negative 5 times 1. Okay, that 1 is what I'm plugging in here for x plus 1, and that would, once we simplify, we would get that y is equal to negative 4. So our whole answer for this problem is 1, negative 4. That is the point where these two graphs are going to intersect. And if we were to go on Desmos and graph these two equations, which I've already done for us, you would see that indeed we have an intersection point at 1, negative 4. Okay? All right, on to the next problem. Here, I already have a box and diamond set up for us, so you already know what's coming. Same as the last one, both of these are equal to y, so we will set them equal to each other. So I'm going to go ahead and say that negative 3, and let me use my really skinny pen here, negative 3x plus 10 is equal to negative 2x squared plus 9x minus 8. All right, so again, since they're both equal to y, we can say that they're also both equal to each other. And now, just like we did yesterday, we got to move everything to be on one side of the equation so that the other side is equal to 0, because that's the only way we can solve quadratic equations. And as you can see, this is a quadratic equation in the making. So let's just go ahead and add this 3x to both sides to move it. And we can also subtract the 10 away from both sides. And notice how I'm just doing the opposite of what their signs already are. Since this one was negative, I added. And since this one was positive, I subtracted. So those will go away. So on the left, just as I wanted, I will have 0. And on the right, I will have negative 2x squared plus 12x minus 18. So now I have a quadratic equation just like the ones I've had you guys solve many, many times. And I'm ready to solve this using my factoring method. So let's set up our box. The first term will go up here. The third term will go down here. And in the top of our diamond, we have negative 18 times negative 2x squared, which will give us a 36x squared. And then my middle term down at the bottom. Okay, so now let's find our two numbers. Hopefully you would find that 6x and 6x are the ones, because 6 plus 6 is 12. 6 times 6 is 36. So let's fill our boxes. So now let's fill out the outsides. In this certain scenario, it actually doesn't matter where we put the negative 2 because both of these have a 6 in it, and negative 2 goes into both. So I'll just stick it up here. And here we'll put a 6, but here be very careful. Negative 2x times what is going to equal 6x? Well, that's going to require a negative 3, right? Because negative 3 times negative 2x will equal 6x. So now that I've done that, I have factored. Let's bring it up here. Okay, I know that we have negative 2x plus 6. And x minus 3 equals 0. This is where we solve using the zero product property. We can say that negative 2x plus 6 equals 0. We have to solve this. It's just a basic equation. Negative 2x equals negative 6. Divide both sides by negative 2. And we get an answer of 3. All right, funny enough, if we had done this one as well, just like we normally would, we would also get an answer of 3, okay? All this means is that there's actually going to be only one point of intersection here because both of the answer choices were the same answer, okay? So now, let's do what we did here and find y by plugging our x value in to one of the original equations. Since I can use either one, I'm going to use the top one because that one just looks easier to me. So y equals negative 3. I'm going to plug in my answer of 3 in for x plus 10. Okay, so this equals negative 9 plus 10. And so I find that y is equal to 1. What this tells me is that my intersection point between these two graphs is going to be at 3, 1. Okay, and let's take a look at the graphs so we can see what's happening as well. All right, I've already graphed it for us here. I've graphed them in Desmos, and if we zoom in, we can see that there is just one intersection point, and it is right here at 3, 1, just like we got algebraically. All right, on to the next problem. We have a radical function here. So again, same starting method, which is to set both equations equal to each other. So we can say that the square root of 4 plus 2x is equal to x minus 2. Now the first thing we ought to do is get rid of that square root because there is an x stuck in it. So to do that, we got to do the opposite, which is to square both sides. You always want to square both sides when you're trying to get rid of a square root. So when we do that, on the left, we end up with just what was inside. And on the right, this is where it gets a little bit more complicated. X minus 2 squared is actually the same as x minus 2 times x minus 2. And we have to give that the proper attention. So let's do a little box here on the side. That's a really, really ugly box. Let's just do it over here. All right, so we actually have to multiply x minus 2 by x minus 2, okay? Because that's what x minus 2 squared means. All right, I need you guys to remember that. So let's go ahead and multiply out. We got x squared, negative 2x, and 4. So really what x minus 2 squared equals is x squared. When we combine these two, we get minus 4x, and we have a 4, so plus 4. All right, so that's what's going to go over here on this side. It's just like one of the homework problems we had yesterday, or classwork problems. All right, so now that we've done that, we can go ahead and start solving just like we did in the last problem. So we will go ahead and move everything to one side. So minus 2x from both sides. So this one will go away. Minus 4 from both sides. So this one will go away. And then here we end up with 0 on the left. And on the right, we have x squared minus 6x plus 0. This actually just turns into 0. So we'll put it there to make it easier for us to solve by factoring, because if there's no third term, we might get a little bit confused. All right, so now let's go ahead and solve this. We can go ahead and make our box and diamond. And solve by factoring. So on the top, we have x squared. Here we have 0. 0 times x squared is just 0x squared. And on the bottom, we have a negative 6x. So when you ask yourself, okay, well, what two numbers multiply to make 0 and add to make negative 6? That's actually just negative 6 and 0. Okay, so what we'll have in our boxes is negative 6x and 0x. So to fill out the rest, we have x and x, we have negative 6, and we have 0. So now we can rewrite in factored form. Let's do that right over here. We have x plus 0, x minus 6 equals 0. So now this one tells us that x is going to be equal to 0 because x plus 0 is just x. And then this one tells us that x minus 6 equals 0. So when we solve that, we get x equals 6. So according to this, we have two solutions, which means we need to find two y values as well. So again, I'll just plug these x values into one of the original equations. I'm going to choose the second one because the first one just looks complicated. So when I plug 0 in for x in the second equation, I get y equals 0 minus 2. So I would end up with y equals negative 2. And then here I would have y equals 6 minus 2, so y equals 4. Basically, my solutions are now 0, negative 2, and 6, 4. But here's the thing. Whenever we have a radical, like a square root graph involved, we are having very high chances of having extraneous solutions. So let's take a look at the graph and see if any of these aren't real on the graph. All right, so looking at our graph here, we can see that 6, 4 is a true solution, but there is no like 0, negative 2 solution here. So really what we need to say is that this is like the true solution, but this one is extraneous. Oh, I got my fat marker. All right, one last problem. This problem is going to be done in a slightly different method now. Need some space. And we're going to do something called substitution. So here, it looks different, right? These were all y equals, but this only has one y equals. So what we're going to do, because we know this y equals to 2x minus 5, we're going to take it and plug it in for y here. That's why it's called substitution. So let's go ahead and rewrite the top equation with this plugged in for y. All right, I've rewritten it so that this is the replacement for y. So let's go ahead and start solving that. First, we need to distribute the negative 2 into my parentheses. So we get minus 4x and then plus 10. So something interesting happens here. These x's actually cancel because 4x minus 4x equals 0, and we get 10 equals 10. So let's take a look at the graph and see what that means. I've graphed the first equation. The second equation is 2x minus 5. So notice how there's only one line. Okay, and what this means is that these two equations are actually just two different formats of the same exact graph. So they are the same graph. They're just two different formats. So when you get something like this where the number equals itself, that means we have infinite solutions.